All right. So today, again, we have a situation where it's no longer in the standard normal distribution where the mean is set to 0, standard deviation is 1, and we're just talking z-scores. Now we're practicing, well, what happens when we don't have a standard normal distribution? All right, what happens if we're given like a word problem? Okay, so let me call on somebody to read this for us, and then we'll see what you guys can do. All right, Alyssa, can you read this one out for us, please?
Data on the length of time to complete registration for classes using an online registration system suggests that the distribution of the variable x equals time to register for students at a particular university can well be approximated by a normal distribution with mean m equals 12 minutes and standard deviation s equals 2 minutes.
Awesome, thank you. Okay, so this is total side note. When you guys go to college and you sign up for classes, it's very, very different than in high school. All right, for college, you have like a whole, set of classes you can pick from to satisfy certain like unit requirements. So you can choose like oceanography, to fulfill like a science requirement, or it can be marine biology, or so there's all these sorts of classes, and then you have a set time where you can go and pick the classes. Obviously the more popular classes get filled up faster, so you just do a little research, look at rate your teacher or rateyourprofessor.com and figure out which class, like have a hierarchy, like a plan A, plan B, plan C. So it's very different than in high school. So I just wanted to like let you guys know, because when I started doing that, like I was completely like, whoa, didn't know what I was getting into. So just a little forewarning for you guys. All right, so let's go ahead and I think it's actually pretty intuitive on how to do a problem based off of this. The only difference is from yesterday's lesson is instead of having a mean of 0 and a standard deviation of 1, you switch those now, right? Now it's mean of 12 and standard deviation of 2. All right, so it says, what is the probability that it will take a randomly selected student less than 9 minutes to complete the registration? All right, so I'm just going to call on somebody and you just tell me what you think we should do. All right, so work this out with me, and let me actually draw the picture first. All right, so here is our normal distribution. All right, and Vic, try this out with me. What do you think we're gonna do to answer this question? Take a stab at it.
So I think it like you have like since it's like you just gotta find like the like where 9 is, what 9 would be like on like this right here. So it would be like towards like the left side of it, like towards like the lower end of the distribution. So therefore, and then from there you can get, since it's excluding 9, so you have technically you can do it like 8 or something, and then covering from 8 to like infinitely, like lower that.
Okay. I see what you're saying. I would be careful. I wouldn't go 8 because you leave out a bunch of answers. Because if you have 8.5 minutes, that would technically still be less than 9, right? So this is a continuous variable. So you actually want to go all the way up to 9 minutes, because it could be like 8 minutes and 59 seconds. Does that make sense, Vic?
Yeah.
Yeah. So don't go 8, because then you're cutting out some of the answer that you want, like anything between 8 and 9 minutes. So go all the way up to 9. So good. This is the shaded region that we want. So in your calculator, what do you think you're going to type in? Any guesses? So Vic, well, first off, what function in the calculator do you think?
think it's like normal distribution, like norm, CDF.
Good. Yeah. And then keep going.
And then you put like, oh wait, you put like, man, I need to refresh. Oh yeah, like -1 E99 or so,
Good. Really low number. Perfect. Keep going.
and then upper is like it will be 14 minutes because since it's the upper part of like the distribution or
Wait, how
so.
many minutes did you say?
I say like 14 because it's like above, like over the mean, which
Where
is
did you
12.
get 14? So so what we're trying to find is this pink region. So what is the upper bound of that pink region?
Oh, so would it just be 9 minutes then?
There you go. Yeah. So just 9. Okay. And then keep going.
So like 12 minutes or like no. Yeah, is it 12 for the mean or
Perfect. Yep.
and then standard deviation is 2.
Perfect. All right. Type that into your calculator. Tell me what you get. Great job. And everybody should be typing it into their calculator just to make sure we all get the same answer. So let me know what you get, Vic.
Yeah, it's 1
Wait, really?
or
Give me like 4 decimals. Make sure you change the mean and standard deviation.
yeah. All right, so it's 0.0227 or 8. Yeah, so 0.0228 or so.
I don't know if you're reading your calculator right, but it's 0.0668. So I don't know, defog the glasses, or I don't know, but I think your 2s maybe are actually 6s. You got it, Vic?
Yeah, I got it. Yep.
Yeah. Okay. What went wrong? Just to make sure, in case anybody else had the same issue.
No, I accidentally put in like the wrong number for like the upper. So.
Got it. Okay, cool. All right. So that's it. The only difference between yesterday and today is we are just changing out the mean and standard deviation to what they give us. And everything else is the same. All right. Great job, Vic. Thank you. Okay, let's go to our next one. Oops, there it is. All right, so this one says, what is the probability that it will take a randomly selected student more than 13 minutes to complete registration? All right, Nathan, help me out with this one. All right, Lishan, help me out with this one. What is the probability that it will take a randomly selected student more than 13 minutes to complete registration? What should I do?
Do a normal PDF, a normal CDF.
Okay, before I do that, let's just practice with the drawing a little bit because I think it helps some people. Where should I put the 13 minutes?
After the 12.
Good. All right. And then which way should I shade?
To the right.
Good. All right. So I want more than. So I'm going to shade to the right. Perfect. Okay. Now go ahead and what did you say? You're going to use normal PDF or CDF?
CDF.
CDF. Good. Keep going.
Is it a 12?
So look at the shaded region. So the pink, right?
Oh, yeah.
What is the left bound?
13.
Good. What is the right bound?
999.
Good. What's the mean?
12.
And standard deviation?
2.
Good. Tell me what you get once you have it on your calculator.
I got 0.3085.
Perfect. Good job, Leong. Well done. Okay. And that is it for number 9.
First one.
Question, yeah.
Do you know how you're like shading to the right? Would you change 13 because on the other ones, like, do you know how it was like shaded to the right? Because on certain calculators, it's like shaded to the left, if that makes sense.
Oh, you're thinking about inverse norm.
Oh, that's only for inverse.
Yeah, that's only for inverse.
Okay.
Yeah.
Thank you.
You're welcome. Okay. Great question. All right, other questions? Okay. All right, let's go to number 10. All right, so for number 10, let me clear this out. All right, so this one says, what is the probability that a randomly selected student, their registration time is between 7 and 15 minutes? 7 and 15 minutes. All right, go ahead and I'll have you guys try it on your own. And then go ahead and put your answer in the chat. So Lily, if you can explain your answer, how did you get it?
I just put 7 for like the lower part, 15 for the upper part, and then 12 for the mean, 2 for the standard deviation, and then clicked enter and then paste and then enter, and then I got 0.927.
Perfect. That is correct. Nicely done. Okay. So I got a question. When the shaded area is on the right side, do I switch the positions of negative 999 and 7? Yes. So whenever it's lower and upper, lower means left, right? On the graph, left versus right. So if it's shaded to the right, if you're looking at your shaded region, the unbounded side, if you're shading to the right, is on the upper side. Did that clarify, person who asked that? Okay, cool. Oh, okay. Got it. Let's go ahead and try the other kind. All right, so I think the normal CDF you guys have down, but let's go ahead and try this next problem. All right, so this is what it looks like in the shaded region. All right, so this one says, because some students do not log off properly, the university would like to log off students automatically after some time has elapsed. It is decided to select this time so that only 1% of students will be automatically logged off while still trying to register. What time should the automatic log off be set at? All right, so if you guys notice, they give us the percentage or the probability. So if they give you that, that means we're going to be using inverse norm. All right, we're going to be using inverse norm. So, oops. I want to draw my graph here so I can visualize. And again, I think this is a very important step. Until you are 100% solid on it, I recommend drawing your normal curve. So something like that. All right, and then the 1%, so the students who take the longest, right? The most amount of minutes. So I'm going to put my 1% at the very top here. I'm going to draw a line. And this shaded region, at the very top here is 1%. Or in decimal form, 0.01. Okay, and then our goal is to find out what is this number, right? What is this number that cuts off the very top 1%? And I mean, at this point, all we know is that it's going to be greater than 12, right? 12 is right in the middle. So the only thing we know right now is that it's going to be more than 12. Okay, so we're going to be using inverse norm, and I want to see if anybody or if you guys can try it. So let me call on somebody to see what they think we might do. All right, let's go to Nick. All right, Nick, what do you think?
So for the area, I would put 0.99.
In what function?
Inverse norm.
Good. All right, so inverse norm, nice. And then you said you're going to put for area what?
0.99.
Good. And why 0.99? Where'd you get that?
Because I did 100 minus 1.
Good. And that's the area to the left. Nice. So this area to the left in yellow is what you want to plug into your calculator. All right, it's always the area to the left. Always the area to the left. So he found out that that is 99%. Perfect. All right, and then what else, Nick?
Then for mean, we have 12 minutes, and then standard deviation is 2 minutes.
Perfect.
And for tail, I put right.
Oh, so close.
Oh, left.
There you go. All right, you did the work of finding the area to the left. You don't want to then say it's the area to the right. Does that make sense?
Yeah.
Okay. So then now what is your final answer?
29.9.
That is not what I got. Did you change? So did you put in your calculator exactly what's on the screen right there?
Oh. Okay. Is it 16.65?
There you go. Minutes. All right. What happened? Just out of curiosity.
Oh, I switched 12 and 2.
Oh, got it. Okay, that'll do it. That'll do it. All right, good. And just in case you wanted to, Nick, if you wanted to say right, you could do 0.01, 12 to right, and you would actually get the exact same answer.
Okay.
So that's another option for you since you have that function on your calculator. Okay?
Okay.
All right. Good job. Any questions?